Gilbert Newton Lewis, born on October 23, 1875, was an American physical chemist. In 1960, Lewis wrote this paper explaining his model and covalent bonding. Before we go deeper into the subject, we must cover some of the basics like covalent bonding. It is a type of chemical bonding formed by the sharing of electrons in the outermost shells. They show us which elements are compatible with each other. The octet rule. This states that atoms tend to bond in such a way that they have 8 electrons in their outermost shells. The periodic table can help us draw Lewis structures by electron configuration and by the group numbers. Before we can draw Lewis structures, we must recap on how to draw electron dot diagrams, so please turn your attention to the wonderful old man.
Scope of this course. This one electron would give us 3s1, and its box diagram would look like that. Sodium's dot diagram would be a single dot. Magnesium's 2 valence electrons would be 3s2. Up, down, paired together. Magnesium's 2 valence electrons are paired. Now, it doesn't matter what side you start putting the dots on. Just for the sake of example, we're going to start by putting the dots on the top. Aluminum has 3 valence electrons, which would look like 3s2, 3p1. That takes care of the third energy level, s and p. So when we draw the box diagram, the dot diagram, we'll have the symbol of aluminum with the 2s electrons paired together and the 1p electron all by itself. Remember, when you do a box diagram, the s's are going to be paired and the p is going to be all by itself, unpaired, in the next orbital. Tin has...
So, don't forget to fill the s orbital first, and then fill the p orbitals one at a time before pairing them up. Now, for Lewis structures. What are they, you ask? The Lewis structure is used to represent the covalent bonding of a molecule or ion. The lines show that 2 elements are bonded together. Leaving them as dots is fine too. Here's a video example.
Together, so we have to put 2 electrons there. Carbon and nitrogen have to be bonded together, so we put 2 electrons there. Step 4 is to add the rest of your electrons to the outer atoms until they satisfy the octet rule. Hydrogen is an exception to the octet rule. It only needs 2 electrons around it, and it already has that, so that's done. Nitrogen, on the other hand, needs 8 to satisfy the octet rule. We've already put down 1, 2, 3, 4 electrons. Let's put down 5, 6, 7, 8, 9, 10. We now have 10 electrons here, the number that we need in the molecule. Step 5 is to make sure that all of your atoms satisfy the octet rule by the end. In this case, hydrogen does, nitrogen does, but carbon does not. Carbon needs 8 electrons around it. We're out of electrons. We can't just add more. We have to move some from an adjacent atom. In this case, nitrogen has plenty of electrons around it that it may be willing to share. So let's move these 2 electrons here. Nitrogen still has 8 electrons around it, but now carbon has 6. That still isn't enough for carbon. It needs 2 more. Let's move these 2 electrons in the bond as well. Nitrogen still has 8 electrons around it. 2, 4, 6, 8. Carbon now has 8 electrons around it. 2, 4, 6, 8. And hydrogen has its 2. All of the atoms satisfy the octet rule. We use the correct number of valence electrons.
So, for drawing the structures, 1. Write the chemical symbol, determine the number of valence electrons, draw on the dots for valence electrons, and rearrange the dots in respect to the octet rule. And that's how you do it.